Okay, so we're going to find 5 planes here. Plane 1 is going to be the bottom, and in 3 dimensions, how do I want to say this? In 2 dimensions, we call the 2 directions we can go x and y.
Yeah, and in 3 dimensions, x, y, and z.
X, y, and z. So the first plane is just going to be the bottom, just the plane z is bigger than 0, or z equals 0, and so we're going to find z bigger than 0 is part of this shape.
Yep.
Okay? Then we have on the edges of a cube, we can pretend the cube has a size of 1. So one of those edges we could say is 1 unit away in the x direction.
Cool.
So we're going to look for x values that are less than 1. And same thing, we can look for y values that are less than 1 in the other direction. Do you have one of the shapes handy?
Are
plane
2 and plane 3 identical to each other?
They sure are. Let me zoom out just a little bit so we can see this.
So this is plane 2 and that's plane 3.
See how we have these nice equilateral triangles?
Yeah. And then plane 4 and plane 5.
Right triangles.
I'm sorry, I said equilateral. Isosceles triangles on the 2 sides.
Yeah. And plane 4 and plane 5 are...
Plane 4 and plane 5 are a little more complicated because these planes just go straight up and down.
Yeah, and but
they sort of tilt.
These 2 planes here are a little more complicated and they tilt. And the first one, I'm going to zoom back in. I can describe mathematically pretty simply as z minus y. The plane is z minus y equals 0, and we're going to go underneath it to be inside of the shape.
Yeah.
And the other plane is z minus x equals 0, and we're going to go underneath it. That's why I make z minus x less than 0.
Yeah.
And then when we execute that code, let me zoom out a little bit.
We get this.
We get this very interesting shape.
There's plane...
You can see
that the bottom is plane 1.
Yeah, that's plane 1. The planes on the sides, those isosceles right triangles, are planes 2 and 3.
And then
in the tilted triangles are
planes 4 and 5.
Planes 4 and 5. So we're able to describe this mathematically. We haven't got to this in the math you're studying yet, but Mathematica allows us to describe this, which is really fun. Because what can we do once we've described the shape in Mathematica?
Well, we can
print it.
We can print it.
Cool.
So let's take a look at the printing.